Okay, so these problems don't say use shells or washers. I want you to figure out which method would be best. Sometimes you can do either one, sometimes only one works, and it's all a matter of the rectangle. So let's draw e to the negative x. Looks like this, and you know it crosses here at 1. Let's draw x equals 0. That's this. X equal 2. That would be this. And then y equals 0. There it is, right there. Okay, so you see the area bounded. So let me just put some dots in there. Okay, so what am I revolving it about? I'm revolving it about the y-axis. So this is the center. Okay, so do I have a choice, or can you think of which would be a wise way to draw the rectangles? I can see that it would not be wise to draw the rectangles perpendicular to the axis of rotation because the top function would change, right? This would be top, this would be bottom, this would be top, this would be bottom. So don't do it that way. So let's do it the other way. Let's draw our rectangle parallel to the axis of rotation. So that gives me the shell. You see the shell there. Okay, so formula for shell is 2 pi radius height, and I can see it's going to be dx integration. So radius is just this x value, right? Just put down x there because it's from the center out. And then the height would be the function, e to the negative x. And then where am I going to build the rectangles from and to? From x equals 0 to x equal 2. You can see that. Okay, let's try another one. Y equal root x. X equals 0. And y equal 2 minus x. Oh, that's a line. Intercept of 2 there. And it's negative slope. So let's identify that area bounded, right? This right here. Now, what am I doing with that? I'm revolving it about the y-axis. Okay, so spinning it here. So this is the center line. So how do I want to draw the rectangles? Looking at this, I do not want to draw them perpendicular because they would have two different top functions, right? So I want to for sure draw them parallel to the axis of rotation. So I'm going to be expecting you to make the wise choice. So volume will be 2 pi radius height. I see it's a dx integration. So let's see, the radius would be from here to here, so that's just an x, right? That's the radius. And then the height, what's the height of that brown rectangle going to be? So at the top of the rectangle will be the line 2 minus x, and the bottom of the rectangle will touch the radical, so minus root x. And then where am I going to build the rectangles from and to? So it would be where the radical, right, where the radical root x runs into 2 minus x. And you could do a bunch of solving, but can you see it's going to be 1 where this would be equal, right? So here's 1, and this would be 0, because that's where we're going to start. Okay, let's try this one. E to the negative x, looks like that. And then y equal 1, that the e to the negative x crosses there at 1. And then x equal 2. Okay, so here, all of this area here, and I'm revolving it about the y-axis. So like this. So this one I could do either way. So I'm just going to start with the shells because I like dx integration. That's just kind of nice to use, right? So this volume would be 2 pi. Radius would be x, right? And height of the function, of the rectangle would be the top 1, subtract off the e to the negative x dx. And I would start building the rectangles at 0, and I would end building them at 2. Okay, so if I drew the same graph over here, so I've got y equal 1 and e to the negative x, and here's x equal 2. Okay, so there's my area bounded. So I will put my answer up here. I'm doing the same. I would get the same answer. I'm not changing what the solid is. I'm just changing how I'm building the rectangles, right? So if I built the rectangles perpendicular to the axis of rotation, that would give me a washer because I can see the hole in there, right? Okay, so formula for washers. Outside radius squared minus inside radius squared, and I can see it's dy integration. Okay, so outside radius, if this is the center, the outside radius goes out to 2. There it is. And then the inside radius would be from here to here. So we might be tempted to put in e to the negative x, but oh no, we needed y's. So to take y equal e to the negative x and solve it, so I'd get a negative ln of y is x. So that's what I would put in here. So that would give me a negative ln of y all squared. And then where on the y-axis would I be building these rectangles, right? Because if it's a dy, these have to be y values. Well, I know I'm going to stop at building them at 1. But where is this? What y value is that? So that's where x equal 2 runs into e to the negative x. Oh, so that would be just e to the negative 2. All right, let's just do this one more here. So if I'm going to take this x squared plus 2, looks like that, x equals 0, x equal 1, and y equal x. Okay, so I'm revolving this about the x-axis. Okay, so this is the center. So do I want to draw rectangles? Well, you tell me, which way would you think would be the better way to draw the rectangles? I'm thinking not parallel, right? Because if I drew them parallel, then I would have a top function and a bottom function, and then a top function and a bottom function. Not a good choice. Okay, so that would mean I'm going to suggest we do perpendicular to the axis of rotation. So there it is. I can see it's a washer. Okay, so formula for washer. So it'd be pi outside radius squared, inside radius squared, dx integration. Okay, outside radius from the center to the parabola, so that would be x squared plus 2. And then the inside radius would be from the center up to the line, so that would just be the y equal x, so x. And then where am I going to build the rectangles from to? Oh, 0 to 1. There we are.